Okay, this lesson is for Thursday, January 26, 2012. Today we're going to review for a quiz that we're going to be taking tomorrow. Really important that you take notes though as we go. Having a few computer issues, so I'll be talking briefly about some of the things instead of actually showing you a picture for certain things. If you actually click on the wave characteristics Prezi, here you'll be able to follow along as we go through um, that presentation. So let's go ahead and click that. And really important, this quiz isn't going to be really extensive much in content, as much content, but it's going to be important that you're able to show that you understand some of the basic concepts. Some of the basic concepts that you're going to have to know are amplitude, wavelength, period, and frequency. You'll be required to be able to actually calculate the amplitude of something, or the wavelength, or the period, or the frequency. It's also important that you understand the difference between longitudinal waves and transverse waves. So in class, I talked about the fact that we watched an animated video of this where the red line was moving back and forth, and it would hit these particles and send them flying this direction across the screen, and they would hit other particles and bounce back. So there's a back and forth motion across your screen from left to right by these particles in a longitudinal wave. The thing that's important for you to know about that is that for longitudinal waves, this takes place in the same direction that the wave is traveling. So these particles are moving parallel to the direction of the wave's motion. In a transverse wave, if we look at these particles, we talked about the fact that these particles, as the wave goes by, are moved up and down. It's more characteristics of the waves that you're used to seeing on TV and in pictures. And in this case, the particles aren't moving back and forth, they're moving perpendicular to the direction of the wave's travel. So that's going to be important for you to recognize in this situation right here. Okay, now these things are going to basically comprise the quiz that you're going to have tomorrow. So it's really important that you're able to calculate for those four things that we talked about and actually represent a wave, draw a wave, or be able to distinguish the difference between a longitudinal and a transverse wave. So let's go ahead and look at amplitude first. So amplitude is the height of a wave, and this is where I was saying I'm having a few technical issues, so I think I have to actually minimize it so we can see it. But for this wave right here, the amplitude is going to be the height. So let's go ahead and see if it'll actually let me draw in here. No, it's not letting me. So the amplitude would be the height for a wave. So if we had a wave drawn here, the height of that wave would be from the top point of the wave, the highest point, down to this baseline, the median. Okay. Another way to find it, if you don't have a nice little line separating your wave in half, is to just look at the very top point of the wave, the very bottom point of the wave, and you see the distance between them, up and down, on the y-axis, and then you can just divide by 2, and that would tell you how much half of it was, because the amplitude is really just the height or the depth of the wave. It shows you the energy of the wave. And that's going to be important that you understand that amplitude is really talking about the energy of the wave. Okay. Wavelength is going to be the next thing that we're going to talk about. And for wavelength, again, in class, I was able to draw on the board for this. Here I'm having some issues with that. But the wavelength is just going to be the time it takes for one complete cycle of the wave. So one complete cycle would be like if the wave started here and you were to start drawing the wave going up and down. Once the wave started repeating itself, that would be a new wave cycle that you'd be measuring. So again, you just look down here at the scale and see how long that wavelength was. Really important that you do look at the scale also, because sometimes for waves, when you see a picture of a wave, the scale will be in seconds. And if it's in seconds, you're actually not measuring wavelength, you're measuring period. And that's going to be the next thing that we go over. Okay, so for period, you're actually calculating the time it takes for one wave cycle. So you'll notice here I put on the scale time in seconds, and in class we drew a picture of the wave, just like we did for wavelength, but in this case, instead of measuring the distance, the length of that wave cycle, we're actually measuring the time period that it takes for that wave cycle to pass us by. Okay, so period is a little bit different than wavelength, but they measure the same part of the wave, one wave cycle. Okay, the next thing and the last thing that you're going to have to be able to calculate is frequency. The two equations for frequency are right here on the side, and this first one is that a period of a wave is equal to 1 divided by frequency. So in this case, we'd use this equation if we were given the frequency and we needed to find the period of the wave. In the second example, we're given the period of the wave, so we can plug it into this equation over here, 1 divided by whatever they gave us, whatever number, and we can calculate the frequency of that wave. Frequency is important because it's actually the number of waves that go by in 1 second. So if you have a phone that's transmitting at 20,000 hertz or 10,000 hertz, that would mean that the phone was transmitting 20,000 waves per second. So that's how many little wave cycles were being sent out per second, which is also really important because the type of device that receives it has to be able to recognize that frequency. Okay, so again, these are the two important equations, and really important that you know how to calculate it from a graph. So if I was to draw a wave here, we could calculate the period, the capital T in that equation, just do 1 divided by that, and you would actually be able to find the frequency of this wave. Okay, that's gonna kind of conclude or be the big picture for this quiz. If you know those things, you're able to calculate those 4 different types of wave characteristics based on information they gave you, or be able to draw it, you should be in really good shape for doing well in this quiz today. The other important thing, as I said, was this longitudinal and transverse stuff. Make sure that you're good on that, so you're able to answer that question completely. That's going to conclude today's stuff. Oh wait, there is one thing. I did assign a worksheet to give you some practice with problems, and let me go ahead and pull that up for you so you can take a look at it. So the worksheet is right here, wave characteristics problems. And on this worksheet, it's going to give you some different examples where the wave is drawn, and what they're asking for here is they've given you the wavelength, and you actually have to calculate the period of the wave. And to calculate the period of the wave is very simple. You just, like I said, you trace the section of the wave that you want to actually mark. Oh, still having problems with that. So you would trace the area of the wave where you would actually want to mark it. This is 1 wave cycle, so the period of this wave is actually 2 seconds. The wavelength was given to you, so it's 5 meters. And from that, you can calculate the frequency using this equation right here, and you can calculate the velocity using this equation right here. I want you to go ahead and make sure that you finish this in class so that if you have questions you can ask. You can see that there's different types of waves drawn here. Again, make sure that you get any help for questions before you leave so you can do well in your quiz tomorrow.